Hello. Hopefully this works tonight. I had a little bit of an issue, but hopefully it's doing all right. Let me know if you can't see anything or if this is somehow not working. But we'll see how it goes. So this week is exam week. We've got our exam on Wednesday. Everybody, Group A, Group B, should plan to come to campus for exam at noon on Wednesday. So in order to help you get ready for that, as you saw on Blackboard, there's no other new material this week. There's no lab stuff to work on. It's just about getting ready for the exam. And then since we're on Wednesday, pretty much taking a break the rest of the week. You can catch up if there's some stuff that you haven't finished up yet, whatever you want to do with that time. But the focus, of course, is just having a good, successful exam. So today and Wednesday morning, I'm happy to answer your questions, whatever you most want to go over. If nobody has anything, I will just kind of go through some of the old stuff and hopefully get to most of the important things. All right. So before we get started with that, though, just one thing. If I can. Yeah. Okay. So here's Blackboard. So hopefully you got this announcement today about the vaccination test status. So I mentioned last week that you had to have this done for the exam on Wednesday. That's not true. You have to have this done by Thursday so that you can come in for lab next week. So everybody has to either have their vaccination data uploaded to this cleared for work system, or you have to have a negative test every week, and that also has to be uploaded to the system, and everything has to be done by Thursday at noon of the week for the next week. So if you're vaccinated, you just have to put your stuff in once, and you're done for the rest of the semester. If you are testing, then you have to do it every single week. On Fridays, I will get a list of people who haven't submitted the stuff and aren't cleared for campus. And if that isn't worked out, then you can't come to campus. You can't do lab. So please make sure that you take care of that. And let me know if there are any questions. All right. So first off, as you're going through the exam or going through studying for the exam, a couple of things to look at first. So one is just the topics here. All of the objectives for this course are clearly stated in each module. So you can see for each week we've got, here are the things you should be able to do. Here are the things you should be able to do. Here are the things you should be able to do. For all 4 of the units that we've done so far, they are also inside the unit right on top here. So I don't, hopefully you've seen those, but if not, it's all right there. That's the stuff that's going to be on the exam. Can you do this? Answers. Because ultimately going to be able to look anything up. It's just paper and pencil and a periodic table. So yeah, as I think somebody asked on Discord, you will get a periodic table. It will have symbols. It'll have names. It'll have atomic numbers and average atomic masses. It will not have charges or anything like that. You should also bring a calculator if you have one that you like. There are plenty in the room, so if you don't have one, we'll have one you can use. But you won't be able to use your phone for that. All right. So if you're here live and there's something in particular you want to talk about, go ahead and put it in the chat or in the Discord under general. And I'll make sure to get to that at some point. While you're thinking about that, I will go back over to the naming stuff because I know that was something that a lot of people wanted to have a little bit more practice on. So we'll go through some of these other naming ones that I left to you to do and talk about how to do those. So for the exam, you should expect that you have questions like this, where there's simply a formula or a name, and then you have to write the name or the formula. Go through figuring that out without really any clues about what category it's in or anything like that. So let's do a couple, and I think that'll be a good place to start. Again, let me know if there's other things that you want to go over as well. All right, so we'll start from the bottom here. Rubidium nitrate. So first thing always when we're naming things is to decide, is this ionic or covalent? Because that's going to change how we do the naming. In this case, we can see that it is ionic because it's a metal and nonmetals. So we know right away this is an ionic compound. Further, we know that it is something with a known charge because we don't have any parentheses. So let's look up on the periodic table and see what we're dealing with. I can find rubidium over on the left, number 37. I can't reach my hand that far, but you see it over there, Rb. And so we can start with that. Another thing that we know about Rb rubidium is that it's going to have a +1 charge. And we know this because in that column, 1A or 1 all the way over there, where everything has a +1 charge. So great, we got half of it. We know that we're going to be dealing with rubidium ions, rubidium +1 ions. So now on the other side, we go with nitrate. Now, nitrate sounds a lot like nitrogen, but you have to be careful here because this is one of the polyatomic ions that you are supposed to know. Remember that list on Blackboard, nitrate was one of the ones that you need to know. So if it was just N, then that would be nitride. Remember that all of the monoatomic anions, the single atom anions, always end in ide, I-D-E. So since we have 8, that's a clue that we're dealing with a polyatomic ion. And at this point, if you haven't, well, I mean, not at this point, but if you're on the exam, you see this, you don't know what nitrate is, you don't know the formula, you don't know the charge, you're kind of stuck. There's really not much way of a chance you're going to get this right unless you're a very, very lucky guesser. So hopefully you've had a chance to remember or to memorize that nitrate has a formula of NO3, so 1 nitrogen and 3 oxygens, and it has a charge of -1. So for each polyatomic ion, you need 3 pieces of information. You need to know the name, the formula, and the charge. That's the only way you can ultimately get the whole chemical formula, because without the charge, for example, we can't balance them and have the right ratios of each. So we've got a +1 on rubidium and a -1 on nitrate. So we don't need to adjust those numbers at all because that is neutral overall, +1, -1. So we can just write this as RbNO3. There's our rubidium nitrate. All right, let's jump over to the left and do this one, FeSO4. So once again, we want to classify it as either ionic or covalent. That's our first step. In this case, we are once again classifying this as ionic because we've got the metal and nonmetals. So now that we know it's ionic, we can start figuring out how we're going to put together the name. And I'm just going to pause for a second because it looks like my internet connection has slowed down. So I'm going to see if it comes back. All right, looks like I'm getting some data back now. Probably moving slowly for you for a second, though. All right, I'm back in the green. Okay. So we'll continue with this one then. So FeSO3 is what we were working on. And Fe we can look up on the periodic table that it's a -2 or 2- ion. So let me get the rest of this stuff out of the way here. So if we've got a 2- ion, and there's only one of each piece here, one cation, one anion, then the cation must also be +2 to balance that. So see how that works? We've got a -2 sulfate, we've got a +2 iron. Again, there's no clever way to figure out that the sulfate is -2. You just have to know that. That's part of memorizing those polyatomic ions. So when we know that the sulfate is -2, then we can figure out that the iron has to be +2 to balance it. So we've got iron 2 sulfate. And remember that when we use the parentheses, it's the charge that gives us the number inside there. Not the number of irons, the charge on the iron. All right. I think we're doing okay internet-wise at the moment, so let's continue. Now, putting these things all together, whoops. One thing that can be good to do for review is just to skip around a bit, so that you get some practice with different types of naming, and where you don't necessarily know which category they're in. So maybe we'll just skip up here to too far. Let's go up here to one of these. This wasn't even a question about naming, but let's see if we can figure it out. Let's look at these two, E and F, right here. I'm going to rewrite those on some blank paper. So we've got CaCO3 and Ni3. All right, let's see if we can name these. We'll start with Ni3 right here. So again, first question, before we get into any of this stuff, is it covalent or ionic? In this case, it's covalent. How do we know that? We know that because it's all nonmetals. There's no ions here. It's just N and I that are covalently bound. And so we can name that using the covalent rules. We don't have to try to figure out any charges or anything like that. We just say how many of each atom there are. So there's one nitrogen, there's 3 iodides, which becomes iodide in the name. And so this becomes nitrogen triiodide. We don't say mono at the beginning when there's just one of the first element. So nitrogen triiodide is the name there. Now remember, we couldn't do that until we figured out that this was covalent. So over on the left here, when we've got CaCO3, we cannot just name it that simply because now we have metal, nonmetal. Now we have something that's ionic. So now we have to go through those other rules and try to figure out all that stuff. In this case, it's a little bit easier because we know that Ca, or we can look up that Ca is calcium. It's in column 2, which means it's one of those known charges. It's always +2. So the calcium here is always +2. And that also means that we don't have to write anything about the charge in the name. We know calcium is always a +2 ion, so we can simply call this calcium and then the anion. So let's take a look at the anion. The anion here is CO3, and that is one of the polyatomic ions that you should know the name for. which is carbonate. All right, so calcium carbonate. Okay, so that's the naming. Then we've got also other things that are going on in this exam. Measurement. We can go through more of that if you want. Also, the subatomic particles. So counting protons, neutrons, and electrons is a part of this one as well. Oh, and let's go through this, I guess. This can maybe be helpful or maybe be more confusing than it needs to be. But at the very beginning of this H4 packet, there was this kind of big summary of all the names. Yes, I can definitely go over electrons. So we haven't actually gotten to valence electrons yet. That is, I think that is next, unless I... Oh no, you're right. No, that's here. That's from week 3. Yes, I will go over that. Just talking about this. So this is kind of a summary of all the nomenclature stuff in a flowchart form. So you could say, well, the first decision is it ionic or covalent or molecular, they say here. And then if it's molecular, you name it like this. If it's ionic, then you have to decide which type of ionic thing it is with the more than one types or not. And then that gives you those 2 different names. So if this is extra confusing to you, just don't worry about it and keep doing it the way that we've been doing it. Yes, let's take a look at valence and core electrons. So we talked about the number of electrons in the atom and how, depending on the charge, it's either going to be the same number as protons or it's going to be something close to there. Well, as it turns out, the electrons are not all in the same area of the atom. They are at different energy levels, and some electrons are closer to the nucleus, making them more stable and lower energy, and others are further away, making them less stable and higher energy. So one way that we can think about what the electrons are doing is by counting those based on where they are relative to the nucleus. So if we draw kind of like a graph, this is often how we explain it. There's various ways to look at this, but this is one way that I like to look at it. And that is to say, here is the distance from the nucleus on the x-axis, and then also energy on the y-axis. So over on the left would mean closer to the nucleus, over on the right mean farther away, and then lower energy is lower, higher energy is higher. And so we can think about like 3 different levels for the electrons. And we can draw them kind of like as buckets because we can say they contain electrons. And so there's going to be electrons that are close to the nucleus at lower energy, then middle, and then high. And then some numbers that you should know. You can fit 2 electrons in the closest level from the nucleus, then 8 in the next one, and then 8 in the one after that. Beyond that, it gets a little trickier, and it's a little beyond what we're going to do in this course. But I think we can all count. I'll give the internet a second to catch up here because it slowed down again. Now, this is also true when we have fewer electrons. So let me show you an example of that. We're going to draw our buckets again, 2, 8, and 8. But this time, let's look at carbon, C. If we look at carbon, sorry, looks like things are slowing down again. All right, I think we're back. So in this case, carbon's going to have 4 valence electrons and 2 core electrons. So the outermost layer is always the valence. Everything else is the core, whether that's just 2 or none or a whole lot. This also gives us some help at figuring out what types of ions different atoms will make. So notice sodium has this 1 valence electron here, and we also know from the periodic table that sodium makes +1 ion. So that means that it can lose 1 electron to form an ion. And that's predictable here because the valence electrons, the ones furthest away from the nucleus at the highest energy, are, and as we'll see in the next chapters, a lot of the things about predicting chemical reactions or predicting what chemicals are going to do comes from knowing how many valence electrons they have. If we go back to the periodic table, when you count it out here, it turns out that atoms on top of each other in the same group have the same number of valence electrons. So when we say that atoms in the same group have some similar properties, that's all an effect of those valence electrons, of having the same number of valence electrons. So like we figured out that carbon has 4 valence electrons. Well, so does silicon, so does germanium, and so on. It's just that valence bucket ends up becoming a different bucket. And then also to answer your questions about the lower ones, we're just not really dealing with those in this class because their electron counting and their buckets get a lot more complicated and tricky. So that's just not something we're gonna mess with in this class. All right, I'm going to give the internet some time to try to catch up again. And hopefully all this stuff ends up on YouTube. I'm noticing now I missed a couple messages yesterday on Discord. They must not have come through. So yes, the lab reports were due yesterday. For group B. And then I guess the assignments all say 9/19 due, which would be yesterday, Sunday night. That's what they should be, but I think I wrote 9/20 in some of them as well. But that's okay as well. You know, if you need an extra day or something on some of this stuff, that's fine. So if you turn stuff in today, that will also count, especially because we're not doing anything else. Hopefully everybody will have a great exam. I'm excited we get to do it in person and on paper. I think that'll be really helpful. So sorry again for the internet troubles, but hopefully you got what you needed. And if not, please let me know. And I'll see you Wednesday.